Today we're focusing on the 2015 question from the AB exam. This is a type 3 interpreting graphs question because we are given a graph and from that we are going to extract information. Sometimes we have a function defined integral. In this case we're given the graph of the derivative. So we've been working on this type of problem for about half the year. But we refreshed it with the most recent functions defined by integrals. The figure shows graph of f prime, the derivative twice differentiable on the interval. The graph has horizontal tangents at -1, so I like to symbolically show that by drawing a little horizontal line there. X equals 1, a little horizontal line there, and x equals 3. The areas of the region bounded by the x-axis and the graph of f prime are 9 and 12 respectively. So that's the provided information. Part A says find all x coordinates for which f has a relative max. F has a relative max or local max when f prime of x changes positive to negative. So we're looking for where f changes increasing to decreasing, so f prime changes positive to negative. This occurs at x equals, well, f prime changes positive to negative right here at -2, at x equals -2. This is worth 2 points. 1 point for identifying the location, and 1 point for justifying why a local maximum exists. 2 out of 9. You're on your way to getting a 2 on the AP test. Get up to 4 out of 9 and you're on your way to getting a 3 on the AP test. Moving on to part B. Part B says, on what open intervals, -3 to 4, is the graph both concave down and decreasing? So f is concave down, is concave down when f prime prime is negative, and f is concave down, we want decreasing when f prime is negative. So we're looking for the locations where f prime is negative. Well, that's from -2 to 4. F prime prime is negative is the same thing as saying f prime is decreasing. So that happens on the intervals -3 to -1 as well as 1 to 3. So the overlap region where f is both concave down and decreasing would be -2 to -1 in union with 1 to 3. This is worth 2 points, and again it's pretty common. You get the first point for having the answer, and then the second point for having the justification. Moving on to part C. Part C is asking us to find the x-coordinates of points of inflection. So f has point of inflections, POIs, when f prime prime of x changes signs. So that's the definition of a point of inflection, when the concavity changes from concave up to concave down or vice versa. We're given the graph of f prime. So another way of saying f prime changes signs would be saying, f prime prime changing signs, would be saying f prime changes increasing to decreasing or vice versa. So we're going to be looking for points where the graph of f prime changes increasing, decreasing behavior. This occurs at x equals -1, x equals 1, and x equals 3. If you want to be more specific, which I think specificity is to your benefit most of the time, you could be more deliberate and say, at -1 and 3, f prime changes decreasing to increasing. And at 1, f prime changes increasing to decreasing. I don't think it's required that you are that specific, but it really demonstrates to the reader that you know what you're talking about. And the better you can get the reader to be convinced you know what you're talking about, the more likely you're going to get the point. It's on you. The onus is on you to prove that you know calculus. Grading for this, again, 3 points. 1 point for identifying the locations. I think you have to get all 3 locations to get that point. And then the second point comes for the justification. So f prime changes increasing to decreasing, or vice versa. All right, moving on to part D is where we actually get to use a little bit of integral calculus. It says integral right there. They give us an initial condition, f of 1 is 3, and they say write an expression for f of x that involves an integral. So, f of x, what I have is equal to what I started with plus what I accumulated from 1 to x of my rate function. And here I'm doing a variable switch so that there's not the same variable in my integrand as in the upper bound of that integral expression. So the function at any given time can be expressed as 3 plus the integral from 1 to x of f prime. That's my general integral. And from here I should be able to evaluate expressions. So we've done the first clause. Now we need to evaluate f of 4 and f of -2. f of 4 would be 3 plus the integral from 1 to 4 of the rate function. The integral from 1 to 4 is, they gave us the area as 12 units, but we are going forward and the curve is below the axis, so we are losing accumulation. 3 minus 12 gives us an answer of -9. We repeat the process at -2. It's going to be the initial condition plus what I accumulate from 1 to -2 of the rate function. The accumulation now is working backwards from 1 to -2. We are backwards and below the axis, so that is gaining values. So this would be 3 plus 9, giving us an accumulation of 12. So our function is at 12, then our function is at 3, and then our function is at -9. This is worth 3 points. 1 point for the integrand. So if you knew that you were supposed to integrate f prime, then that gets you 1 point. 1 point for an expression of f of x. So if you did the full initial plus accumulation, that gets you 1 point. And then 1 point if you found the values of f of 4 and f of -2. Be sure to smash that like button, comment, subscribe, buy my merch, click the bell for notifications.
You gotta have a good outro.
I'll work on my outro.